Okay, so in this video we'll see some examples, some mechanisms, and we'll calculate the f value, the degrees of freedom for these mechanisms. Okay, so the first mechanism A, okay, so it has how many links? The fixed link is 1, and this link 2, link 3, and link 4. So n is equal to 4. Okay, now J, so it's 1, 2, 3, and 4. So all the kinematic pairs are lower order pairs, so J is equal to 4. So F is equal to 1. Okay, so if we use that, and also we need to mention H is equal to 0 for this case. Okay, and we also know that J is equal to J1 plus 2J2 plus dot dot dot, right? And all the other higher order kinematic pairs are 0, and only J1 is there, which is equal to 4. Therefore J is equal to 4. Okay, so the degree of freedom is 1 for this case. Okay, what about for B? And how many links? So fixed link is 1, and this cam is 2, and this roller 3, and this follower 4. Okay, so n is equal to 4. Okay, and what about J? So if you see between 1 and 2, it's a hinged 1, and 3 and 4, it's hinged, so that's 2, and 4 and 1, it's hinged. So in total J is equal to 3, but 2 and 3, it's not a lower pair, it's a higher pair, so J is just 3, and H is 1. Okay, that's between 2 and 3. Now what is F? F is equal to 3 into n minus 1 minus 2J minus H, which is equal to 3 into 3 minus 2 into 3, which is 6, minus 1, which is equal to 9 minus 7, which is equal to 2. So it has 2 degrees of freedom. Okay, fine. How about this? If you notice, there isn't much difference between this figure, okay, and this figure, except the link 3 is bent, okay, in this case, where there is no such bend in this case. Okay, so which means even for this case F is going to be equal to 1. Okay, what about for this mechanism for D? So n is equal to, if you count, n is equal to 5. Okay, and how about J? J is equal to okay, first how about J1? So this is 1 and 2, 3, 4. Okay, what can I say about this one? This is also lower pair and lower order lower pair, because it's just connecting link 5 and link 2, right? So 1, 2, 3, 4, 5, 6. So J is equal to 6. Sorry, and there is no higher pair, so F is equal to 3 into 4 minus 12, isn't it? So the degrees of freedom is 0. Okay, so if the degree of freedom is 0, it has a special name. It's called structure. Okay, we can't call that as a mechanism, we call that as a structure. Okay, fine. Now for this case, it looks complicated, but even for this one, let's see. N is equal to 6, so one is fixed, and this one, okay, and this one, this total one, that's 3, and this small link is 4, and this link is 6, and this link is 5. Okay, this link is 5. Okay, so total 6 links. And then what about J? So this is 1, 2, 3, 4, 5, 6 and 7. Okay, so J is equal to 7. Am I right? 1, 2, 3, okay, 4, 5, 6, 7, 8. I have counted it wrongly. So J is equal to 8. So now what's F? F is equal to 3 into 5 minus 16, which is equal to minus 1. Wow. So it seems a structure with a redundant constraint. Okay, so that's what the negative F means. Okay, let me make sure that I have counted J correctly. 1, 2, 3, 4, 5, 6, 7 and 8. Yes, so F is minus 1. So we can't have, that means we can't have any motion for this, as well as for this case when F is equal to 0. What about for this case? For this case, N is equal to 3, J is equal to 3, so F is equal to 0 if we substitute in that formula. So this is also a structure. Okay, fine. So this is how we need to calculate. But if you notice, so last time we have discussed that this is actually a PPP kinematic chain, and with PPP we can have a mechanism, right? So if we can have a mechanism, it should have F at least 1, right? But it doesn't look like, according to the formula it gives 0, but in actual case it should be 1, right? So there is a problem. Okay, there is a problem where in the Kutzbach criterion. Similarly, there is a problem in this example as well as in this example as well as in these two examples. Okay, so let's see where is the mistake, and how can we redefine this Kutzbach equation so that we will be identifying the effective degrees of freedom. Okay, that we will discuss in our next video. Thank you.